Good afternoon. Today we'll talk about this Unit 11, which consists of a very interesting chapter, Value Engineering and Quality Analysis. Now, first of all, what is value engineering? Now, every organization has certain products, and that products goes through different life cycle. Introduction stage is growth, maturity, and decline stage. So, every organization wants to improvement over the performance of the products so that it can say, create demand for the products. Therefore, value engineering or value analysis, which are interchangeably used, or that is an important and powerful approach. Is an important and powerful approach for improvement in the performance of the product and systems or procedures and reduction of in cost without jeopardizing their functions. The terms value analysis and value engineering are used almost interchangeably. Other terms used to convey the same concept are value assurance and value management. So, to say that value engineering is a tool which helps us to improve the performance of the existing product or the systems and procedures and reduction of the cost of production of the product, but the most important that it should not jeopardize their function. That means whatever function they were previously say offering, that function should not be anywhere, should be hampered. So value engineering is a tool which is say improvement for the performance of the products. Now, L.D. Miles defines value analysis in books of in his book Techniques of Value Analysis and Engineering in 1961. So, L.D. Miles, who published a book on value analysis in 1961, he defined as an organized creative approach which has for its purpose the efficient identification of unnecessary cost, that cost which provides neither quality nor use nor life nor appearance nor customer features. That means, according to Miles, value analysis identify the unnecessary cost, and according to him, which are the unnecessary cost? The cost which neither provides quality of the product, nor it helps in use for the product, nor it gives a longevity of the product, nor it gives the appearance or the cost. By incurring that cost, the product feature is not very good, nor customer are satisfied by that cost. So identify in his identifying the unnecessary cost is the important feature of value analysis. Now, generally there is a difference comes between value engineering and cost. Now, what cost reduction? Now, value engineering, conventional value engineering is very say now say contemporary topic, whereas cost reduction is conventional. Now, it is function oriented. What do you mean by function oriented? That means we try to say get rid of some functions which are not necessary in a product and which is unnecessarily there in a product, but it is item oriented. So cost is related to the item, where value engineering is related to the functions. And value engineering is an innovative approach and idea. That means value engineering say gives you new idea, new technique of producing a product or improving the product, whereas cost reduction is a conventional, is follows the past practices, what has been done by the organizations, and that practices is followed subsequently. Now it exercises maximum creativity. That means value engineering is always related to creativity, creating new things. But Cost reduction is analytical approach. You analyze only and try to reduce the cost. Now, there could be divergent and convergent idea. That means ideas may go different ways or ideas may come together. But in cost reduction, there is only convergent ideas. There is cost visibility on the following functional basic. What is the basic function of a product? What is the secondary function? What are the unnecessary function? And what is essential function? So, if there is unnecessary function, we try to get rid of this unnecessary function, thereby you can reduce the cost. Whereas costs are visible on the following parameters in cost reduction. What are the part and components? What are the process? What are the materials used? What are the what are the materials and how much the materials? What are the labors? What are the fixed costs? How is the transport and what is the packaging? What is the maintenance and what is replacement and miscellaneous? So we find out the cost on this particular parameters. What are the cost on a particular part or component? What are the cost on a particular process? What are the cost on different materials? What are the cost on labor? What are cost on overhead, transport, packaging, maintenance? All these are taken into considerations. Whereas in a say value engineering, we find what are the basic functions, secondary functions, unnecessary function, and essential functions. Now, the sixth difference is there is a teamwork approach. In a value engineering, we find a team approach and a spirit among the members. That means members come together, try to have a value engineering, that to have an innovative idea, creativity. Usually there is individual approach, no team spirit. In a cost reduction approach, there is only individual approach and no team spirit. And it is a value engineering is a multidisciplinary approach, means say teams from different departments, say marketing, operations, finance, and IT sometimes also come together to have a creative idea and have some innovation. So that's why it's called multidisciplinary. There is no multidisciplinary approach. This is only one department, which is value engineering approach does not compromise with performance, quality, and reliability. This is very important. At the outset, I have told in my definition, value engineering though improves the product, its process, and its say perform, but it will not jeopardize, it will not compromise with the performance, quality, and reliability. The cost may be reduced, but the performance and quality and reliability should not be compromised at any cost. And there is a tendency toward compromising quality and reliability. When you reduce cost, when there is reduce a cost, there is always a tendency toward compromising the quality and reliability. And it is a systematic and sequential approach, whereas a cost reduction is an arbitrary and ad hoc approach. So again, I'm saying, say value engineering is a team approach. It's all the team members come together and there is a spirit among the members. Usually there is individual. In cost reduction, it is individual. It is multidisciplinary, whereas there is no multidisciplinary approach. And value engineering never compromise with the performance, quality, and reliability. And there is a tendency toward compromising quality and reliability in case of cost reduction. Companies sometimes they compromise with the quality and reliability by reducing the cost. That means they may use a different types of raw materials or a outdated technology, whereby or something by which they reduce the cost, whereas they may not have the say good labor force. They may also increase the labor force, decrease the labor force. Thereby they can compromise the quality and reliability. Whereas value engineering goes for creativity, value engineering goes for innovation. Thereby it never compromises with pop. And value engineering is a systematic and sequential approach. And this approach is arbitrary and ad hoc. Now, If you go through the historical background of value engineering at its origin in the General Electric Company (GEC). Now, as a as a result of the World War II in 1945, or many materials were in short in supply. That means many raw materials or which were used by the General Electric Company, they were not in supply. So LD Miles, who is associated with GC company, he thought of why not we find out certain materials which can be which to identify the substitute materials without sacrificing the quality and performance. He organized a formal methodology in which team of people examined the function of products manufactured by GC. Through team-oriented, through team-oriented creative techniques, they made changes in the products to lower their cost without affecting their utility and quality. This methodology was given the name of value analysis. L.D. Miles, who wrote in his book 1961, is generally recognized as the father of value engineering. So, L.D. Miles is called the father of value engineering. The background of the value engineering is that GC company first, it was originated in the General Electric Company, and it was in the Second World War. The company faced short in supply of the raw materials. So LD Miles with a committee, with a team of members identified to substitute the materials without sacrificing the quality and performance of the products produced by GEC. So these people, formal methodology in which team of people examine the function of the products manufactured by GEC. So through team-oriented creative techniques, they made changes to lower their cost, and they become successful to change the techniques, the creative techniques. They made changes in the products to lower their cost without affecting the utility and quality. This methodology was given the name value analysis. L.D. Miles, who wrote his book in 1961, he is considered as the father. The first organization to initiate the formal value engineering program was Navy Bureau of Ships in 1954. In 1959, Society of American Value Engineers, that is called SAVE, was set up to propagate the philosophy of value engineering. Many companies in USA, UK, Japan, etc. subsequently set up formal VE programs. The Department of Defense in US encouraged application of VE in defense projects. A number of success stories of VE and VA are reported. So, the first organization to initiate the formal VE program was Navy Bureau of Ships. And in 1959, there was SAP was created, that is Society of American Value Engineers, to propagate the philosophy of value engineering. Many companies in USA, UK, Japan, etc. subsequently set up formal value engineering programs. So, value engineering in Indian context. In India, the value engineering or analysis is now a well-recognized program, and many organizations in military and navy as well as in other public and private sectors have built up directorates or cells of value engineering. A professional society, Indian Value Engineering Society, Invest, came in to create awareness into value analysis and value engineering, and they publish a journal, organize conferences, provide other services. Now, it is considered as an effective management tool. So, value engineering or value analysis is a well recognized program, and in many organizations in military and navy, as well as most of the public sector and private sector, they have created their own directorates or cells of value engineering. Now, Invest was created. What is the work of Invest? Invest publish certain journals, organize conferences, provide other services, and it is now considered as an effective management control. So, after it was originated in GEC and used in, say, Navy Bureau of Ships in 1954. This value engineering also become important in Indian context, and Invest is responsible for that. And value and functions. Types of value. The term value is used in many different ways. Now, generally we say frequently confused with monetary price or cost of an item. When you talk about value of this item, we talk this the value is of a pen is 10 rupees. However, value is not synonymous with cost. Value may be perceived as the ratio of some of the positive and negative aspects of an object. So, the value can be considered as a composite of quality and cost. It is more in terms of worth or utility. That the ratio of quality to cost can be treated as the value of a product. If its cost can be reduced by same quality, or quality can be improved with the same cost, or quality can be improved with the same cost, then value improvement can said to occur. So again, what has been there in this slide, I am explaining. Value and functions are not same thing. Generally, when you talk about value, we talk about the price or cost of an item. However, value is not the same with value may be perceived as the ratio of sum of positive and negative. What is the ratio of positive and negative aspect of an object? Say, value is considered as a composite of quality and cost. It is more in terms of worth or utility. It is the ratio of quality to cost. Quality divided by cost can be treated as the value of a product. If cost can be reduced for the same quality, or the other way around, if quality can be improved with the same cost, we can easily say that. So value improvement can said to occur. So before I go to next slide, I can say that value is not same as cost. Cost value is used in many different ways. Value is not synonymous with cost. Value is defined as the ratio between quality to cost. If cost can be reduced for the same quality, or quality can be increased for the same cost, then value improvement can said to occur. Now, what are the types of value we generally find? The terms value can be divided into following types. Use value, the properties and quality which accomplish a useful or purpose or service. For example, the pen, what is the use value? The pen helps us to write on a paper, or a pencil helps us to write. A mobile phone helps us to communicate, isn't it? A car helps us to transport. So every object has a use value. A toothbrush has the property, use value of brushing our teeth. The properties and quality which accomplish a useful purpose or service. That is called use value, for which the product is developed. Then there is esteemed value. The property features or attractiveness which cause us to want or own it. The properties or features or attractiveness of a product. Suppose a car, there are certain properties, there are certain features, there are certain attractiveness. So when you purchase a car, we look for that properties, whether the properties are there or not, whether the features are available or not, whether the attractiveness is present or not. If it is not there, we don't purchase it. So for purchasing a car, it's a hatchback, it's a attractiveness, isn't it? Now there are features, say it is say the gear system is automatic. So attractiveness, features, the colors, that is called esteem value. I can say that esteem is such a value which attracts the customers to purchase a product. Cost value is the cost of producing a product. So the sum of labor, the cost of labor, material, various other costs required to produce it. And the properties or quality which enable us to exchange it for something else we want. That is called exchange value. Exchange value. So first is use value. Use value is the properties and quality which accomplish a useful purpose or service. Esteem value is the properties, features, or attractiveness which cause us to want or own it. Cost value is the cost of labor, material, various other costs required to produce it. Exchange value, the properties or quality which enable us to exchange it for something else we want. Function is the basic purpose of an item or an expenditure. It may also be a characteristic that makes the item work or makes it sell. Miles define function as the basic purpose of each expenditure, whether it is for hardware, the work of a group of men, a procedure, or whatever is to accomplish a function. Now, the function of a TV, every product has a function. Function is the basic purpose of an item or an expenditure. It may also be a characteristic that makes the item work or makes to sell. Suppose we want to write on a paper, so we have to purchase a pen or a pencil because pen and pencil can only makes us to write. Miles defines what is defined function, the basic purpose of each expenditure. Let it be hardware or work of a group of men, whatever a procedure or whatever is to be accomplished is a function. So, types of function. Value analysis discipline deals with functions of items, product, systems, and procedures. So, it is a functional approach, customer-oriented approach. So, identification of the function therefore constitute an important aspect of value engineering. The term function is used to mean the purpose or use of the product. So, value engineering always deals with the function of the items or the products. Therefore, it's called a functional approach. It's a customer-oriented approach. So, identification of the function is the basic important aspect of value engineering. The term function, as I've already told you, it means the purpose or the use of a product. Functions can be of two types. Basic function, the primary purpose of the product. Suppose we have a mobile phone. The mobile phone has a primary functions is to connect others through the phone. But it has certain secondary functions like taking photographs, other purpose not directly serving the primary purpose but supporting it. Many a time poor value may result in because the functions have not been precisely understood and redundant or unnecessary functions have been imposed. So every basic functions and there are secondary functions. So other purpose not directly serving the primary purpose but supporting it. Many a time what happens, poor value may result in because the functions have not precisely understood. So therefore, organization goes for value test. Value engineering is essentially questioning the attitude, looking at the function and cost. So LD Miles design a set of value tests to ascertain whether there is a scope for value improvement. So again, Miles who design a set of value tests. By a test, we can know whether there is a scope for value improvement. If the value tests are honestly applied, there is bound to be room for improvement in most of the products, systems, and procedures we come across. Some of these questions which can work as thought starters for developing better value alternatives could be as follows. So, what is the work of value engineering test? Value engineering test is to ascertain whether there is a scope for value improvement. So, Mild gives a value test, and he also of the opinion that if these tests are honestly applied, if you rigorously employed without any impartiality, we apply this, there is bound to be room for improvement in most of the products, systems, and procedures. Now, can the design be changed to eliminate the part? In a product has many parts. So, the first test is, can the design be changed to eliminate the part? Can you purchase it at a lower cost? Does it need all its features? Is there anything better for the intended use? So, first we have to see whether we can change the design to eliminate the part. Then, can you purchase the part at a lower cost? Does it need all, suppose a product has different features, does it need all its features? Or is there anything better for the intended use? Can a usable part be made by a lower cost method? Can a standard part be used? Is it made on proper toolings considering the quantities involved? Are there any newly developed materials that can be used? Can two or more parts be combined into one? 10. Can any specification be changed to the affect the cost reduction? So these are the 10 value tests by which we can easily ascertain whether there is a scope for improvement or not. First thing is saying that can the design be changed to eliminate any particular part? Second, he says that if any, can you purchase it at a lower cost? Then all the features which are available in a product is necessary or not? Is there anything better for the intended use? Is there anything better for the intended use? Can a usable part, that means part made by a lower cost method, that means any lower cost method can be applied to, can a standard part be used? That means there not be change in the part. Is, is it made on proper toolings considering the quantities involved? And are there any newly developed? Are there any new materials available that can be used? Yes. By applying the value test, we may come across core value areas which are responsible for unnecessary cost. The sentence itself speaks what is the importance of value test. So, by applying value test, we come across core value areas. Core value area means what is? That area which are responsible for unnecessary cost. Core value results is unnecessary cost. This could be in the design of the product. That means the faulty design, faulty procurement, faulty handling and storage of materials, faulty production process, packaging and distribution of the final product. Once we are able to identify the core value area, we can focus on our attention on this so that these unnecessary features can be eliminated. Very important. So, what is the benefits of value test? Value test identify the core value areas which are responsible for unnecessary cost. Now, these core values can be inherent in the design of a product, or sometimes it is in the procurement of raw materials or other materials, spare parts, and handling and storage of the materials, sometimes also the production process, also the packaging of the finished product and distribution of the final products. Now, he says that once we are able to identify the core value area, we can focus, so the industrial engineers can focus on the unnecessary features which can be easily eliminated. So, value tests are very important because it helps us to identify the core value areas which causes unnecessary cost in the organizations. So, if core value areas can be identified, we can easily give our attention on those areas so that we can eliminate them easily. Another way to identify core value areas is through function cost matrix approach. If a function is relatively less important but account for a larger percentage of a product cost, it is a potential area for value improvement. By determining alternative cheaper ways to achieve that function, we can reduce the cost and improve value. So, he says that another way to identify the core value is through function cost matrix. We have to find out what are the functions available in a product. Now, all functions are of equal importance, or if some function is found out to be very less important, but the cost which is incurred for that function, it is very high, larger percentage. That means if a product is 100 rupees, nearly 30 rupees is spent on a relatively less important functions. So it is a potential area for value improvement. That means here the industrial engineer has to look for determining alternative cheaper ways to achieve that function. So we can reduce the cost and improve the value. So that is called cost matrix approach. Here we have to find out which are the relatively less important functions and what are their percentage of expenditure, what is the percentage of expenditure of the total product cost. If it is larger percentage cost, production cost accounts for less important functions, we have to go for the improvement. So value test may come across four value areas which are responsible for unnecessary cost. Now, in simple terms, a soundly conducted value analysis program should be essential to provide answers to the following. If we soundly or say do a value analysis, it will provide the what is the item, what does it do, how much does it cost, can anything else do the same thing, how much does that cost. So here value analysis program answer the five questions. What is the item? Whether the item is a say pen, what does it do? What is the function of that? How much it cost to produce? Then can anything else do the same thing? Is there any alternative for the pen? If that alternative is available, then how much that it will cost? We'll compare the cost of the new product along with the our existing product. And mind you, if the new product can serve the same purpose, the same functions of the earlier function without hampering the quality, then we can say our value engineering program is successful. So value program should essentially provide, when you conduct a value analysis program, it must able to give five important answers to the questions. What item the organization is producing and how does it cost, how much, what does it do, how much does it cost, can anything else do the same thing, how much does it, yes. We shall briefly outline the salient features of the three different approach to conduct a value engineering. These are job plan due to merge, tertiary method, first functional analysis system technique. First we will discuss the A1, which is very important. Now, since the job plan due to merge is a very well recognized approach, we will deal with in this section. Now, the job plan due to merge has five important phases: information phase, function phase, creation phase, evaluation phase, investigation phase, and recommendation phase. Now we'll see what is information phase. Now, yes, A is general phase. What is general phase? Throughout the application of the entire job plan, the techniques of this phase must be diligently applied to create the right environment for the value engineering job plan to be effective. There are five techniques associated with this phase. Use good human relations. What is that? Use good human relation? It will be said that considerable personal contact is necessary throughout the project. The use of good human relation means assistance in place of resistance. That means we should require the cooperations of the people rather than we require the resistance of the people. So in the general phase, what you do? We use good human relations. That means good personal contact is necessary throughout the project. Then second is inspired teamwork. This is one of the easiest to talk about, yet one of the hardest to accomplish. When you talk about teamwork, it is very easy to say or very easy to write, but it is in reality, it is one of the toughest to accomplish. It calls for subordinating personal prominence or ego in the interest of the group as a whole. It calls for subordinating the personal prominence. That means Every individual, every person has a ego or prominence. He wants to dominate the others. That we have to sacrifice it. While we work in a group, in a team, it is necessary that we should get rid of our prominence or ego in the interest of the group as a whole. We want group achievement. We don't want here the individual work on specifics. We should avoid generalist and work on specific. Concentrate data information on specific problems must be studied. Only opinions and hearsay can be expected when talking in generalist. So use good human relations, have a personal contact, we have cooperation, have assistance rather than resistance. We should say get rid of our ego, we should get rid of our say prominence and work as a group. And in the third general phase, we should work on specific problems, not on general problems. Then overcome roadblocks. What is that overcome? In any organizations, there are some dissidents can be found. That means there are certain groups who will oppose the ideas. These individuals, knowingly or unknowingly, will use every means at their command to resist the change. So change is very hard to digest. So any organization, if there is a change is going to occur, there will be certain group of people who will say oppose this, and it is important to able to recognize the roadblocks. That means who are those people who are opposing and what are the obstacles in the value engineering, then take steps to overcome them. Mars has in fact compiled an impressive list of killer phrases which people use to kill an idea. It is very crucial to avoid such mental roadblocks. Apply good business judgment. Business decision and judgment must be based on facts. Poor business decision and poor judgment become prevalent when personal opinion and feelings takes control. To apply good business judgment, one must be resourceful, able to think, should able to pursue new knowledge. So these are the general phase. Use human relations, inspire teamwork, work on specifics, overcome overloads, apply good business. Information phase. The objective of this phase is to gain understanding of the project being studied and obtain all essential facts relating to the project, as also to estimate the potential value improvement. This phase comprises three techniques. Secure facts. Information gathered must be authentic. It is one of the most arduous tasks, difficult tasks. This type of information required will be technical specification, dimensions, grades, tolerances, quality, appearances, environmental specification, test conditions, engineering drawings, production, sample, actual or model of it, production data, operations, speeds, rates, output and stock levels. It also deals with the cost data, what is the material cost, labor cost and overhead cost, work specification, what is the workplace layout and the standard time, features preferred by the consumers, development, testing and service records, and quantities involved, scrap rates. So this type of information is required here. Then determine the cost in order to direct towards those areas promising the greatest return on time and efforts in value engineering. The complete and accurate cost must be secured. Fixed cost on specification and requirements. By establishing a relationship between cost and specification, a mean is presented by which the latter two can be quantitatively evaluated. Extreme care should be taken during this phase to be sure that true facts are gathered, accurate costs are secured, and these costs are truly related to the specification and requirements. Once the technique of the information phase has been used to secure pertinent data, then see the function phase. The objectives of this phase are to define the functions that product quality actually performs. So after the information, we have gathered all sorts of information I have given you. Then comes the function phase. The objective of the function phase to define the function that a product actually performs and is required to perform, as well as the relate this function to the cost and worth of providing them. When you talk about functions, it should be related to at what cost the functions are coming, and it is the worth of providing them. The two techniques of this phase are major part of the functional approach. When combined with the other techniques of the job plan, it produces a systematic approach which is different and more productive than any other product improvement or cost. So define the functions. This is one of the most crucial stage in value engineering. The method of functional analysis requires functions to be described with only two words, with a verb and a noun. By then, it should be concise function description, reduces the possibility of detailed systematic approach. The rules of function description are determine the user's need for a product or service, use only one verb, what does it do and how does it do, where possible, nouns should be measurable, verbs should be action oriented, avoid passive and indirect verbs, avoid goal-like words or phrases such as improve, maximize, minimize, optimize. List a large number of two-word pairs when select the best pair. This technique attempts to determine the relative importance of various functions. Through this technique, a descending order of importance of the function is established along with the relative value of their importance. A pair comparison technique to determine the numerical value of the various functions is very simple and effective to use. In this, pairs of functions are compared. It is sought to determine which is more important and whether the degree of variation is major, medium, or minor. So, some case studies in value engineering. Value engineering is very extensively applied in product design, system, and procedures, and a very large number of case studies have been reported in books, journals on value engineering. In many of these case studies, large amount of savings have been reported in Indian industries. Value engineering applications have been reported from Tisco, Telco, Escorts, Hindustan Lever, Kelvinator, Railways, Godrej, Bell, NTPC, L&T, Raymond, and a host of other public and private organizations. It is also known to have been applied in Indian Army, Navy, and Air Force. So, value engineering has been extremely applied in product design, system, and procedures. So, it is used in prominent, say, public sector as well as private sector. So, make design changes to reduce the construction cost in a large garage of a trucking function, protect trucks, general explanation. These are all case studies. So, benefits of value engineering and concluding remarks. Value engineering helps in improving the efficiency as well as effectiveness of products. That means efficiency when better way of doing, right things, right way of doing, and right things are done. Effectiveness. It enables people to point out the areas that need attention and improvement. As I've already told you, value engineering gives you the idea. Value engineering gives you the idea where is the problem lies and where it should be improved. Provides a method of generating ideas and alternatives for possible solution to a problem. So it provides a method of generating idea. It provides a means of evaluating alternatives, including intangible factors. So it also provides what are the alternatives available. It also gives a vehicle for dialogue, and it also documents the rationale behind the decision. What is the reason? Why should you go for such and materially improve the value of the goods and services? That materially means it improves the quality of the product. So next part we'll discuss introduction to quality assurance. We have discussed about value engineering. Value engineering is nothing but improving the product perform. We all must have come across the word quality in different contexts. In everyday life, we talk about quality. This product is qualitative. all of us look for good quality in goods and services. So we all realize that the major achievement of industrial revolution has been the ability to mass produce a variety of goods of uniform quality. The classic example being automobile. We'll agree that characteristics which set apart Japanese goods as a superior or class is precisely their quality. That means when you talk about Japanese automobile, automatically we take their say, class apart. That's why they are called qualitative in nature. So we always, when you purchase a product, we always think of a qualitative product or qualitative service. And we all that major achievement of industrial revolution has been ability to produce. Due to industrial revolution, we can able to produce mass production and with a uniform quality. Now, what is the concept of quality? Even though we talk about quality, it is not easily defined. Before we go for a definition, it will be good idea to give your own definition. One of the accepted definition of quality is fitness for use. An equally good definition is conformation to requirement. Note that in both the definition, quality is defined as relative to use rather than general characteristics that may be intangible. By this simple yet practical definition, if a product and service live to the expectation, it is of high quality. On the other hand, extra fine finish or using materials that are far stronger than the required does not add quality to item unless somehow it causes item to conform to this requirement better. That is means a product is said to be qualitative when it satisfies the expectations of the customers. You may use say stronger, better raw materials, but if does not say conform to our requirements, we call it the product is failing in the quality. The term cost of quality is often mis. Cost of quality is a measure of the cost to the firm for a lack of quality. It is very difficult to measure, often cannot be found in accounts book. One has to be carefully back calculate. Quality costs are distributed throughout the organization. Most organizations include only the cost of quality control department, whereas the cost of inspection, measurements carried out in production departments are often ignored. More importantly, cost of bad workmanship, wastages, rework are often not included in quality cost. The careful examination of quality cost should account for prevention, assessment, control cost, and cost due to lack of control. Quality is free, but it is not a gift. This statement sums up the opinion that effective permanent quality improvement is difficult to achieve, but more than plays for itself in increased productivity. So, when you talk about quality, cost of quality, we generally talk about the quality control cost, quality control department, cost of inspection, measurements carried out in production department. So, quality control should account for also prevention, assessment, control cost, and cost due to lack of control. Then, quality management. Quality assessment is an investigation of the level of quality being achieved. Quality control, on the other hand, begins with assessment that includes action to eliminate unacceptance quality. The typical quality control program is based on periodic inspection followed by feedback of the results and changes or adjustment whenever necessary. So, quality assessment is nothing but investigation of the level of quality being achieved. To what extent we have achieved the quality. Quality control, on the other hand, begins with assessment and include actions taken to eliminate the unacceptable quality. Thus, this product whose quality is unacceptable. The typical quality control program is based on periodic inspection, followed by feedback of the results. When you make every week or every day, we make a periodic inspection. What is the feedback of the results and what changes or adjustment we have to make? Quality assurance includes quality control, but also refers to emphasis on the quality in the design of the product, processes, and jobs and in personal selection and training. Total quality control refers to the managerial commitment to the quality so as to include the quality aspect in every functional area of work. So quality, it also includes the behavioral science based on techniques like quality circles, zero defect programs. Quality assurance in an idea is quite old, but a systematic inclusion of quality assurance in the organization is a 20th century phenomenon. Statistical methods of quality control were first proposed by Stuart in 1925. Intensive training courses in statistical control, popularized by American and Japanese industries, contributed to much of the success of quality control program. Recently, the concept of quality circle has been a runaway success in Japanese industries. A quality circle is a group of employees whose assignment is to identify the problem, formulate the solution, and present the management with the suggestion for implementation. It is getting increasingly popular with employees and management in India. So, quality assurance is an idea quite old, but it is a 20th century phenomenon. Statistical methods of quality control were first proposed in Stuart in 1924. Intensive training courses was popularized by American and Japanese industries. And recently the concept of quality circle has been a runaway success in Japanese industries. We find quality circles. Quality circles is a group of people, generally the employee of the group of people whose assignment is to identify the problems. Quality organization. Common mistake is to view quality as a responsibility of the department that produce the goods and service. Lack of conformance, however, cannot be a problem of design or even advertising. Consider the manufacturing automobile transmission. If the gears are improperly designed, the transmission will fail despite the best quality of manufactured gear. So, the quality is everyone's business, must be understood by everyone in the organization. Quality begins at the product concept stage and extends throughout the development, production and delivery and use of an item. So, quality is not the business of any single individual. Quality starts from the production concept stage till it's used by the end consumers. Causes of poor quality can occur anywhere in the organization, from top management to the shop floor worker in accounting, production, sales, service, and any other functional area of the management. Some quality problems have roots outside the organization, such as defective supplies from a vendor, incorrect specification from a customer. So, quality say problems may also may be external in nature. That means it comes from the vendors, suppliers, or it may come from incorrect specification from a customer. To achieve success, a major commitment to quality must be made up by top management. It must be visible to all employees. Major quality problems often cross departmental lines, so barriers to system-wise action must be removed. Quality improvement must be established as a positive approach rather than blaming the assignment. In general, training is the key to the success of quality control. Keeping this principle in mind, several alternatives exist. Acceptance sampling, one of the powerful statistical techniques. For this technique is generally used in those situations where items are inspected in batches, generally known as a lot. For example, you may receive a shipment of 10,000 electric bulbs. You have to decide whether to accept the shipment or return it back to the supplier. The acceptability depends on the acceptance quality of the lot, which in turn depends on the use price you are willing to pay for. Suppose if you decide to accept the average fraction defined less than 5%, then to ascertain the actual quality, you may decide to inspect each and every bond. Such a strategy is 100% inspection. However, many often it's expensive and impractical. In such cases, more intelligent ways to so when any consignment comes, we have to either check each and every item or we can go for a sample test. In the latter case, it is sometimes if not possible to have check every and each and every item. So we go for a statistical technique that is called sampling in technique. The idea of sampling inspection is to inspect only a small portion of a lot and inform the quality of the lot based on the quality of the sample. Acceptance is based on the inference made from the sample. Hence, the 322 capacity planning is known as acceptance. Typically, a lot is specified by size n and fraction small f of defectives that are expected to present. Suppose I have taken 100 items, so 100 is my n. The fraction of defect is 2%. If out of 100, 2% are defective, then I will accept that. If it's more than 2%, my f is more than 2%, then I have to reject the item. So in other words, sampling might be work and sample must be representatives of the law. When you talk a sample, you should be representative. Single, there are two types of sampling plan. One is single sampling plan. In single sampling plan, we use a single sample. We will first consider a single sampling plan in which we accept and reject the decision on the result of a single sample of n items from capital N items. That means if from the 100 items, if I take 10 items, 100 is my capital N, 10 is my small n. Each of the 10 items is inspected and categorized either acceptable or defective. Such a plan is known as sampling by attributes. And we will, if the number of defective items in the sample exceed the predefined COT level, that is C, if the entire batch is rejected. The entire batch is rejected. So if I say that out of 10, if 5 items more than 5 are defective, then I will reject. Another is your double sampling. Double sampling is extension of the single sampling plan to double. In double sampling plan, after having inspected, there are 3 choices depending on reject the lot, accept or draw the second. All products and services have a certain amount of natural variability because of the variation in the inputs as well as imperfection in the process. For example, different quality of raw materials could have been used. So he says that every services have variability because the inputs we use have variability. The process has variability. The process variability may be measured by a process standard deviation, which indicates how much the products will vary if the process is in control. So, control chart was developed by, say, Stuart in 1931. The control chart is a visual display of the result of an inspection process. Now, control chart is a graphical method of depicting whether the production process is in control or not, whether the production system is defective or not. So, control charts rapid feedback to the ongoing production process method, somewhat different from acceptance sampling. So, samples are taken as soon as they are available rather than waiting for the completion of a lot. So, the basic difference between control chart and acceptance sampling is that control chart we can say is online and say acceptance sample is offline. That means all the lot is produced, we go for acceptance sampling. Quality control chart is a graphical whether the forms process or processor are meeting their intended specification. As I've already told you, control chart is a graphical method of representing whether forms, products or process are meeting the intended specification. If problems appear to arise, the control quality chart may be used to identify the degree by which they vary from those specifications and help in error corrections. Generally, there are different types of control chart: mean chart, P chart, NP chart, C chart, U chart, MR chart, and individual MR chart and customer data control chart. Control charts give clear guidance to whether to adjust the process or when to leave it. Control chart drive process improvement. Control charts are accepted by all types of customer. Control charts provide a written record or chart. There are 3 lines in a control chart: upper control limit, lower control limit from a corridor within, and There is a central line. Outside the limitations of UCL and LCL, the quality measured is considered abnormal and requires intervention in the relevant process. If any product sample goes beyond the upper control line and below the lower control line, we say that the so all control charts have three basic elements: the central lines, usually the mathematical average of all the samples plotted, upper and lower statistical control limits that define the constants of the common cause of variations, and performance data plotted over time. Control chart, as already I've told you, were working for Bell's lab in the 20s. And thank you very much for this today's discussion.